guys, the graph is, there's a difference. First of all, I want you to know that heat and temperature are not the same thing. Okay? Temperature is a measure of kinetic energy. Heat is the amount of stuff, energy, transferred in order to raise something in its temperature or to change phases. Okay? So, for any substance, this is your generic graph. But for each substance, you have very specific things. Like, for example, for water, and for every substance, this represents solid. This represents melting, so solid to liquid. This represents the liquid phase, heating up. This represents liquid to gas. And then this represents the gas heating up. Okay? For your substance, you have to know the melting point, which for water is 0, and the boiling point, which for water is 100. Okay? And if you are going to be asked to do a problem with anything else, they will have to give you all of that data. You have to be given heat of fusions, heat of vaporizations, specific heats for all of your phases, and melting and boiling points. Okay? For water, we kind of expect you to know the 0 and the 100. So I usually do most of my problems with water, just also it's easier for you to picture in your head. Okay? So, what we need to do is we need to look at the problem. We're going to start at -5. So -5 would be like down here. So if this is -5, and then we're going to go to 85, which is about right here, okay? What I do is I recognize that I'm going to have 1, 2, 3 steps to my problem. I'm not going to have 5. I'm not even going to use vaporization. I'm not going to use the specific heat of steam. But I am going to use the specific heat of ice, the melting of ice, and the specific heat of the liquid. Okay? So, if you also want to number these, that might help. This is going to be step 1. This is going to be step 2. This is going to be step 3. And I'm going to add them together to get my overall heat that I'm asking over there in the green bubble. Okay? So, for step 1, let's look at what we have. We've got heating up. We're going to use a diagonal line. So my heat, which is represented by Q, is going to be M, mass, times C, specific heat, times delta T, which is change in temperature. My mass is 10 grams. My specific heat is 2.03 joules per gram Kelvin. And my change in temperature is from -5 to 0. We don't care about the positive or the negative, we just want the change. And so yes, it will be 5. Now, because this, remember we said a change in Kelvin and a change in Celsius will be the same. So, this will be fine. The grams will cancel out, the Kelvin will cancel out, and so we have 10 times 2.03 times 5. What'd you guys get for that step? 101.5, and the units are going to be joules. Got to keep track of that. Make sure that you know if it's joules or kilojoules. Okay, the second step. For the second step, there is not going to be a delta T. We're going to have our heat is equal to our heat of fusion times, I guess let's write amount. Because if we look, our heat of fusion, in this case, is 6.01 kilojoules per mole. So, what is my amount going to have to be in? Moles. Okay? So, how do I convert 10 grams to moles? 10 grams of water is, 18 grams of water is 1 mole. And so you could just set it up like that. I think you end up getting like 0.5556, right? Moles. So, when you multiply through here, right, your moles are going to cancel out. Okay? Would you guys prefer me to replace this with 0.5556 moles? Does that look better?
Yes.
Or does it matter? Can you see it either way? Let's just leave it. There's not an overwhelming vote. So I get 3.34. But what's the unit here? Kilojoules. Because this is in joules and I'm eventually going to want to add them, I'm going to go ahead and take this one step further, multiply by 1,000, right? Is it 1 kilojoule, 1,000 joules? And so this will be 3,340 joules for that step. Then, for the third step, we're back to a diagonal line. Q is MC delta T. Our mass is still 10 grams. Our specific heat now is 4.18 joules per gram Celsius. And our change in temperature, we're already at 0. We're going to go up to 85. And so we have 10 times 4.18. What'd you guys get for this step? Say it louder, Ethan. 33?
53.
Is this right? Did I get a second on that?
Yes.
Okay. And so now that's the end of our heating up. And so now we're going to add up these three numbers. Has anybody already added it up?
6,984.5.
Say it one more time slowly and loud.
6,994.5.
Okay, does everybody get that? So we have answered this part of our problem. Okay, Maria, take a break.